Okay, this is line 22a Capacitors Sungas Turbine Neutrino gases 5G Wow Seti, part 236. I tried to fix this and it's doing its own thing here. So this is the number that I got from the wow signal. If you look at it down here, I guess these are the original ones I did in January, and I did each one and then I got tired of doing this. So there's the number equation there. Okay. Again, if you want to see the equations, they're on the Idea Girl Says WordPress site on a static page for you to look at, okay? There's the equation there, the division, and then the number that goes with it. There it is over here. So when we Google 0.0071 capacitors NASA Google, up come these PDF files. This was originally done January the 9th. Today's June 23rd, 2012. Okay, so the Apollo 11 mission report, November 1969, comes up from the www.hq.nasa.gov. And it says Centaur Britain Certain Command and Service Module Orbit Lunar Model Sent. The capacitor shown is an actual part of electromagnetic. The next PDF is Designing Magnetic Components for High Frequency DC Converters. This is trs-new.jpl.nasa.gov, and it's another PDF file which require only a diode and a capacitor. The filter inductor is built in B equals that number. The next PDF to come up is the Flight Wing Service Pressure and Boundary Layer Data Report from NASA the government by SG Powers in 1997, a temperature controlled variable capacitance absolute pressure. There's the number there again. Next is experimental study of vane heat transfer and film cooling, and that's ntrs.nasa.gov. And this is thermal capacitance with increasing blowing ratio and increased coolant penetration with increased. There's the number there again. NASA Apollo 11 mission report comes up with a bunch of numbers. Again, the capacitors is being mentioned again with that number. Counterfeit parts, meteorology, soldering, workmanship, FMEA. That's from aaq.auburn.edu. The following slides are actual NASA photographs resulting from improper workmanship. And it's about a capacitor electrolyte leakage. So obviously there's a problem with this capacitor. Wire and cable harnessing and protection procedures, wire and cable from ptkgroup.ru. Commercial wire and NASA spec and other space application types. Additionally, a variety of components on a PCB such as the capacitors and fuses. Next comes up Juratic TR77417 from www.theriac.org. And that's from GF Goth in 1977, which is the same year that we got the signal. It says Defense Documentation Center, NASA Scientific and Aerospace Reports. The resistor and capacitor section is 3 and 7T values for relays are set. The next thing that comes up is System Characterization and Online Mass Property Identification of. This is from ssl.mit.edu. It's from D. Berkovics. Supported the flight program of Spears and the NASA reduced gravity. The gas is regulated to 35 psi and fed through an expansion of capacitor to the 12, and again the numbers. Mass driver 2 127A test is IS, and this is from ieexplore.ieee.org. From W. Snow, it says recharging power supply, a large capacitor bank with SCRs, and to recharge the sector capacitor banks between from the NASA Ames Research Center. Next is the turbine airfoil aerothermal characteristics and future coal gas from dlbegelhouse.com. That's August 2011. Gas-based systems are hydrogen-fired cycle and oxy-fuel cycle. Both the first gas composition S-gas represents the dosing gas turbine. The NASA E3 energy efficient engine, high pressure turbine airfoil was chose. Next is capacitors similar to 0.0071 UF, and it's got voltage is 100 V, and there's the part number and the length and 500 V. And then this MNQC comes up. It says inlet section, compressor, combustion system, turbine, exhaust stem, and exhaust diffuser. This is some sort of invention. It's from Simons Westinghouse. It's the MNQC combustor cross section, syngas, natural gas syngas, air extractor, fuel nozzle, air. Well, you can see it there. I'm not going to read it all. So this is a GE Sungas Turbines to debut at IGCC plant by Jeffrey Goldmere, PhD. Fuel flexibility platform, later GE Power and Water. GE recently shipped its first 2 Sungas turbines to Duke Energy's integrated gasification combined cycle IGCC power plant in Edwardsport, Indiana. I think it's Indiana. I'm not sure. I'm assuming it is. Which is expected to be the largest, most advanced commercial IGCC plant in the world when it enters service in 2012. Which is very interesting because this is now 2012 and this is talking about it opening up in 2012. IGCC technology converts coal to a gas known as synthesis gas or syngas. Pollutants, NOx, SOx, mercury, and particulate matter that are removed from the gas. The IGCC also offers the ability to capture carbon dioxide, CO2, prior to combustion, providing an efficient, economical, and commercially feasible means of reducing this greenhouse gas when compared to a traditional coal plant. That's interesting because I think one of the formulas comes up using where it produces carbon dioxide, and maybe this invention is to help you remove it and convert it to energy. A pioneer in the development of IGCC technology, GE has provided equipment for several milestone IGCC projects, including the Cool Water Demonstration IGCC plant in Barstow, California. GE's IGCC technology also has been operating on a commercial scale at Tampa Electric's 250 MW Polk Power Station since 1996. The 2 GE 7F Sungas turbines recently shipped to Duke Energy's Edwardsport IGCC plant are expected to operate on cleaner burning syngas fuel produced from coal. When complete, the plant is expected to generate up to 618 megawatts of electricity. And that's from penenergy.com. Conversion in dense neutrino gases, pendulum and flavor space. One of the major achievements of the Department of Energy's Advanced Turbines program was to break through previous limitations on turbine temperatures. Using a combination of innovative cooling technologies and advanced materials, the advanced turbines that emerged from the department's research program were able to boost turbine inlet temperatures to as high as 2600 degrees Fahrenheit, nearly 300 degrees hotter than in previous turbines, and achieve efficiencies as high as 60%. Another way to boost efficiency is to install a recuperator or heat recovery steam generator, HRSG, to recover energy from the turbine's exhaust. A recuperator captures waste heat in the turbine exhaust system to preheat the compressor discharge air before it enters the combustion chamber. An HRSG generates steam by capturing heat from the turbine exhaust. These boilers are also known as heat recovery steam generators. High-pressure steam from these boilers can be used to generate additional electric power with steam turbines, a configuration called a combined cycle. A simple gas turbine can achieve energy conversion efficiencies ranging between 20 and 35%. With the higher temperatures achieved in the Department of Energy's turbine program, future hydrogen and syngas-fired gas turbine combined cycle plants are likely to achieve efficiencies of 60% or more. When waste heat is captured from these systems for heating or industrial purposes, the overall energy cycle efficiency could approach 80%. So that's fossil.energy.gov. Okay? The key words are core and power handling, transformers, mode control, modulators, magnetics and switching circuits, and wing pressure and span, syngas fired gas turbine, NASA, Google, and line 22A. Okay? I guess that's the end of that one. So we're going to go on to the next set. This is going to be a whole series for line 22. It goes all the way over to line 22E3. Okay? Stay tuned.